Hello and welcome to Algebra II with Mr. Clausen. Today we are going to talk about real-world two-variable inequalities, and specifically for this video I am actually going to go over just one example. And in my class, we're going to have a specific workday where we're just going to go over real-world examples of two-variable inequalities. But before we get to that day, I have this video that I'm going to have you guys watch just to start getting an idea of how to process some of this and what some of these examples might look like. So with this specific situation, I'm going to go to one of my favorite video games. It's a turn-based strategy game called Civilization 6. So we're going to go through this problem, we're going to look at all the different aspects that are typically involved with the two-variable inequality, and then we're going to solve this question. So in Civilization 6, one of the players that you can play is the Greek Empire, and there are two units that it has. One is the hoplite, which is a spearman-like character, and then an archer, which is probably pretty self-explanatory. It's a dude with a bow and an arrow. And they are effective for early gameplay. So in Civ 6, you have these different eras and stages. And the first era, the Stone Age, that type of thing, you have very primitive units. So as you build cities, they create units of production that can be used to produce your military units. A hoplite requires 65 units of production in order to build, and archers require 50 units of production in order to build. And so these two units take resources in order for them to be produced. The city of Sparta, which is a city in the Greek Empire, is near an aggressive civilization, and the Emperor of Greece decides that the city should focus on its production towards military for the next 100 turns. If Sparta creates 9 units of production per turn during this time frame, what number of hoplite and archers can be created after 100 turns? Okay, and so what we're going to do is we're going to create a two-variable inequality. We're going to graph it to look at these possibilities of the combination between archers and hoplites that can be produced during this time frame. So how do we do this? We got to figure out some information whenever we're looking at this, and to get started we have to make our original inequality that we want to base this off of. So if we're looking at this, typically what we want to do is we're going to look at the cost of archers plus the cost of hoplites has to be equal to some total cost. That they can be valued at. And so if you ever want to do something like this, we have to create a component for each of these pieces. So an easy way to do this is that if you look at hoplites cost 65 units of production. Archers cost 50 units of production. We know that Sparta can create 9 units of production per turn for 100 turns. And this all gives us information that we need. What I can tell you about this piece of information here is that after 100 turns, there would be a total of 900 units of production at Sparta's disposal for creating military units. And so now the question is, how many of each of these do we make? You could argue that if you have this piece of information, we could say, well, we could make approximately 18 archers and a little less hoplites. But how do we put that in the form of an inequality? Because this is one of the things that I want you to start practicing. So if you take that idea in mind that if you had 18 archers would use up the 900 units of your production, what you're really doing is you're saying 50 times the number of archers you have is less than or equal to the total 900 units of production you have at your disposal for the city of Sparta. And so we can apply that same idea to the hoplites and say 65 hoplites and have that same situation in context. And this is a pretty standard circumstance. You have your costs for each thing, and you set up a variable for each of those items so that however many you decide to make, you can attribute it to the total that you have at your disposal. And so now that we have this inequality, we can actually go and make a graph of the situation. So if we say 65, which is the cost for a hoplite, and we multiply that by the number of hoplites you choose to make, plus 50 times the number of archers is less than or equal to 900. What this allows us to do is just use any combination of hoplites and archers that can be produced with 900 units. And so to do this, typically what you have to do is you have to label your x and your y axis. So if we go and we identify this axis as one of our types of units, this is going to be a typical thing where you have to identify this. Let's identify the y axis as hoplites, or h hoplites. And let's look at the x-axis here. And let's label this as our archers. Now, it doesn't necessarily matter which orientation that you choose unless it specifically tells you in the problem. I'm just choosing it for this specific format so that we can see how this would work. Now that we've labeled this, we'll have to label our axes as well. And so typically, if we're looking at this, we could use 18 archers. So let's just use that as a basis here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we have 18 right here. And the reason I'm concerned about that point is we want to graph this boundary line. Well, this inequality is in standard format. And what I've talked about in the past with standard format, when you see something like this, is just figure out what your x and y axis is. So if we say that h is equal to 0, just temporarily, you go 50a is less than or equal to 900. A would have to be 18 when h is equal to 0. That tells us our x-intercept. And then if we go and we want to look at the other axis here, let's assume that a is equal to 0, and we see how many times 65 goes in the 900. We'll see that h is equal to 13.8 when a is equal to 0. So we wouldn't quite get to 14, so 5, 6, 7, 8, 9, 10, 12, 13, 14. All right, so we're going to cross about right there, right at 13.8, right at 18. Each tick mark is representing a unit. And now we're just going to connect the dots. And we're going to graph our boundary line. And we can go with a solid boundary line like we talked about in the previous video because this is an equal to type inequality. So that means you have a solid boundary line. And in order to finish this question and to look at what our possibilities are, we might be able to intuitively figure out and understand that this portion of the graph isn't going to be our solution. But if we test 0, 0, I would still go and use this as a test point, because you understand that your inequality should work at 0, 0. If you choose not to build any hoplites or archers, this should work. So I would do this more so from a perspective of when you're going and you're testing this and you're plugging everything in, does it work the way that you expect it to? And if we go plug everything in and we say 0 is less than 900, this works out, then you know you set up the inequality correctly. And you can shade everything on the inside here, and those represent your solutions. So with that said, that's all I have for you. I just wanted to break down an example and look at how we could look at some of these type of circumstances and analyze them. It's just like any other type of situation, but we get an opportunity to go and analyze some real world examples in class. So with that said, let's do some math.